Hello everybody, my name is Ari and I'm the founder of Practical Programming, a coding bootcamp here in New York and in Chicago. And every week we do these live sessions which are both fun and interactive. And I'll answer your questions at the end of the session. You could post your questions in our live chat. And by the way, let me know if you could hear me well, if my mic's working fine. And what we're going to be doing today? Today we're going to be talking about Python lists. Python lists. Now, list is essential data structure in Python, and it's very important. So I'm going to show you how you could create a list, how you could manipulate a list, how you could add stuff to a list, how you could work with list, and why would you want to use a list in the first place. Also, spoiler alert. Next week we're going to be talking about Python for loops, so please subscribe to my channel and you won't miss a thing. And again, we're doing these live sessions every week on Wednesdays. All right, so I'm going to be coding right now, and if you want to use the same Python environment as I'll be using, you can find the link in the description to this video. It's actually Google Colab. You could just Google it, or you can find the link. And we're gonna start. All right, so let me switch to my computer. All right, so first thing first, what is a list? List is a data structure, and I know it's a little bit confusing, especially for beginners, because if you go to official Python documentation, it says that list is a data type. Potato patata, so it's pretty much data type and data structures. These words used interchangeably. All right, so I call it data structure. Why? Because it's pretty much like a box. You could put stuff in it. All right, you could put items. So a list is a collection of items separated by a comma. Let's create one. So first thing first, we need to create a variable name. Let's say a box, randomly picked variable name. Then I use equal sign, and to create a list, to initialize a list, I need to use square brackets. Bam, done. How do we know that this is a list? You might say, hey, this is like really simple because you use square brackets. Oops, sorry. Because you use square brackets. All right, now there is my favorite command type. If you pass box in it and if you run it, you see in fact this is a list. Okay, now what I want to do, I want to add a couple of items or elements. You could call them whatever you like. How would you do that? Now probably some of you, if you took some Python courses in past, you might say, oh gee, I don't remember. I think something like append. All right. Now, it's not a guessing game. You don't have to guess because there is another function that we could use. It's by the way, it's a Python built-in function. It's dir, D-I-R. So D-I-R, if I run it. So what it's going to get me, it's going to get me a list of all attributes of that object. And we're talking about box right now, which is a list. It's an object, all right? Now, here we see all attributes. And the first we see dunder methods. Why dunder methods? Funny name, right? Because double underscore. So people don't want to say double. They say dunder methods, all right? Now we scroll down, dunder methods. And then here we got bunch of methods that we could actually use. So let's take a look. What do we have here? So we have append. I mean, it kinda makes sense because yeah, append. If you want to append something, there is append, right? But then there is insert. Oh, gee, which one should I use? Then there is extend. Extend also sounds like something that you could use. But anyway, so the point I'm trying to make is using that dir, you always find methods that you could apply to that object. Now, suppose you don't know which one should you use, like append or insert, like because they kind of like sound familiar, sound the same, right? So if you don't remember or if you don't know, that's okay. Why? Because what you could do, you could use command help box and let's say append, and if you run it, all right. Okay, so you see help again. Help is Python built-in function, and you can find all these functions if you Google Python built-in functions. So help is Python built-in function, and it gets description of that method. So append, what it does, it appends an object or item to the end of the list. All right, so let's give it a try. Okay, so box is our list, and the reason I actually using this, the reason why I'm using this box name, because I wanna like explain that list pretty much like a box. You could put stuff in it. All right, so let's do box, and then I'm gonna do append. All right, and then let's append a bunch of random numbers. I don't know, let's say 5. All right, oops, I misspelled. Always happens to me. Obviously not box, but box. All right, so now it's working. So let's do one more. Let me just copy it from here and let me run it here. All right, so then I'm gonna do, I don't know, 1, and then let's do one more. Okay, so we could do 2. So let's take a look what do we have in our list. And here we have list that contains bunch of numbers separated by a comma. All right, now the main thing you have to check is that here you see square brackets. Again, square brackets means that this is a list. All right, now we have a bunch of numbers. All right, now so the whole idea behind the list, you have to understand it. You don't use a list just for the sake of it, or maybe just like a file. You don't want to park your data in a list, right? So you create a list because you want to do something to these items, to these numbers. What you could do, a bunch of things you could do. So for example, what you could do, you could sort, and list could be sorted because it's ordered collection. So you could use method sort. And again, and you see, by the way, it's like really cool tool that I'm using right now. It's kind of giving us these hints. So you see sort, and then it gives us that description. So you don't even have to run that help because pretty much everything is here. So sort is a built-in method. And if you see what just happened, now you see we have sorted these elements in ascending order. We could also sort them in descending order if we, and again, you see, if I point here, okay, so here I could use this argument reverse, and I could switch reverse to true. And if I run this again, now my list is ordered in descending order. All right, so one more time. List is an ordered collection, contains a bunch of elements separated by a comma. Now, the main thing you have to know about the list, and especially if you go to job interview and if you try to get a job as a Python developer, so the second question they would ask you if list is mutable or immutable. So what does it mean? Mutability is a very important concept in programming. So it pretty much means can you change that object if that object can be changed, right? So in this case, what do you think? List is mutable. List is mutable because we just appended a bunch of numbers to that list, and we also sorted that list. You could sort it in descending order, right? So it's mutable. You could change that object. And by now you're probably wondering what was the first question that I mentioned. All right, so the first question, if you go to job interview, would be what are the built-in data types in Python? All right, so and you're probably going to like mention the string, integer, float, and by the way, last week we did like really good piece on data types, so please check it out. And then you're going to get to list, and when you get to list, second question would be, is it mutable or immutable? All right, so please write it down if you're taking notes. By the way, it would be a good idea. So list is mutable, so it can be changed, right? So we could manipulate it. We appended bunch of items. Also, we could remove items. You see, box, append, and let's say I don't need one anymore. Oops, I just appended. I'm sorry. I was trying to run remove. All right, so you see I got two of them. So now I'm going to do remove, and I'll remove and one. And if I run this one more time, bam, like box, and you see it's gone. So since you can add and remove elements from a list, it means that it is mutable. All right? Okay. Now, another thing that you have to remember, it also might come up during the job interview, if list is homogeneous or heterogeneous. Oh, what I'm talking about. All right, so let me show you what I'm talking about. So, okay, we don't need this one anymore. All right, so here, what if I do something like apple, and then, so it means that list by nature heterogeneous. It means that list can hold different data types at the same time. So it means that, you see here we have 5 and 2. These are integers, whole numbers, and then we got apple, which is a string, right? So completely different data type. So one more time, by nature it's heterogeneous. However, you don't want to do something like that. Why? Because it makes no sense. Because like I mentioned before, you create a list because you want to do something to these elements down the road, right? So now there is no way you could sort these items. That won't work because you cannot compare 5 and apple, which is a string, right, to different animals. So although by nature it's heterogeneous, so by convention it's homogeneous. It's supposed to be homogeneous. You're not supposed to store different elements, and when I say different elements, I mean elements that are different data types within a list, right? So what we should do, we should remove apple, yeah, all right. So now let's run it again, box. All right, so you see it's removed. So you should always keep the same elements, the same data types within a list. All right, cool. Let's do this quick exercise. All right, let's do something practical. What could be practical than a shopping list? All right, so let's create shopping list. All right, and before I before what I was doing, I just initialized an empty list. And what I did on line 1, it was pretty much like you just create an empty box, right? But also, if you know that you want to put some elements, you could actually just insert them into that list. So for example, what I want to buy? I want to buy apples, and then I want to buy, let's say, oranges, and then I want to buy what? I know, like bread, bunch of random items. All right, now you see, so here, let's stop right here. So here we have a shopping list, which is a list that contains bunch of strings. And again, I'm keeping it homogeneous, so because it would make no sense to have apples, oranges, bread, and then bam, like 1 or 2 or whatever, right? So it's got to be homogeneous. All right, cool. So, and then I want to call my wife and ask her, all right, so what else should I get? All right, so how would I do that? So I could create a variable name item, and using built-in function input. So then I could ask a user, what else should I get? And here I could do something like that. What else should I get? All right, cool. So let's run this. All right, so what else should I get? I don't know. Get me some mango. All right, so mango. Main. All right. So now let's take a look. Shopping list. If you run this, all right. Oh, okay. So what's missing? We didn't append it, so let's append it. How would you append it? So then it's going to be shopping list, and then append, and then item. Okay, if you run this, now mango is on my list, you see? So that's like, suppose you want to create a shopping list, and then you could append some stuff to this list as you go. Now, before I have mentioned that list is an ordered collection. All right, so what does it mean? It means that all these items in my list, they are in order. And I'm not talking about like sorting per se, like ascending or descending order. However, you could also sort it in ascending or descending order, because Python knows alphabet, and you could go from A to Z if you apply the same method sort. And by the way, let me show you what I mean. So again, if we run sort on these elements, and if we do this shopping list again, so now you see it's sorted in alphabetical order, A, B, M, O, all right? So that's what we got. But actually what I mean that you could access elements by indexing. That's why it's ordered. So what I mean exactly? So let me show it to you. So shopping, okay, so shopping list, and here we have 4 items, right, for elements. Now apples is the first one. Now if I want to fetch the first element from my list, I could index it, and the index of the first element always will be 0, because in programming we're counting starting at 0, 0, 1, and so on. So let me show you what I mean. You got to use square brackets. Now these square brackets got nothing to do with the list, and pass here index 0, and you see by that index we just fetched apples. All right, now if I do 1 here, so then I'm gonna get bread. Why? Because bread is the second element. So you probably got the picture by now. So apples is 0, bread is 1, mango is 2, and oranges 3, right? So you could think of it as, let's say, an apartment building. People move in and out, but then someone always lives in apartment A1, right? And even like, usually I receive a bunch of junk mail, and sometimes they don't know my name, so they would just put like resident. So by that address, by that index, we could fetch an element, from a list, right? So again, apples would be 0, because it's the first one. And even if we let me make my point, and what I'm gonna do, I'm gonna reverse the whole list, and I'll sort it in reverse, true, in a descending order. So now you see we got oranges first, and if I rerun the cell, I haven't changed anything here. So if I rerun the cell, bam, now I got oranges. So the point I'm trying to make, no matter what we got there, oranges, apples, like whatever, you could always get that first element by index, and if you want to grab the first element, it always will be 0. All right? I hope that makes sense. Now, and again, let me remind you that we have this live chat it's going, and you could ask me questions, and at the end of the session I'm gonna give you a couple of minutes, and I'm gonna answer questions if you have any questions. All right, cool, let's continue. So now if the first index is always 0, so the last one, in this case it's apples, is -1. So let me show you what I mean. So first of all, we could count, and we could say, all right, so 0, 1, 2, 3. And if I pass here at 3, I'm going to get apples. However, now list could be really, really long. List could hold millions, and I'm not kidding here, millions of elements, like literally. You could like easily put million million elements into that list. So now, and you don't want to count them like 0, 1, 2, 3. You don't want to do something like this. So if the first one is always 0, so the last one is always -1. And you see now I fetched apples. So you see in both cases I achieved the same result. I fetched the last one. So index could be positive, like with a plus sign, or index could be negative. Now, and you could think of that minus sign pretty much as a direction. If sign is positive, then you go from left to right, right? 0, 1, 2, 3, and so on. Now, if index is negative, then you start at -1, -1, -2, -3, and so on. Depends how many elements you got there. So, for example, -1 got me apples, which is the last element in my list. So if I want to grab bread, so I could do -2, and now you see I got bread because why? Because this is -1, apples -1, so bread -2. So you see we're kind of moving in the opposite direction. So this is called indexing, and you could get elements from a list by index. All right? And again, the first one, please remember that, the first one is always 0. The location of item, no matter what item is always 0. And the last one, if you don't want to count, going to be -1, all right? Now, this is cool. So this is indexing. But what if you want to grab a couple of elements? Now, suppose I want to grab oranges and mango, all right? So suppose I want to grab these two. If you want to grab these two, so then you need to use something called slicing. Okay, so how slicing works. And here I'm just going to write some pseudocode, and pseudocode just plain words. Okay, so questions, a million things. Yeah, okay. Now, so we're trying to grab oranges and mango at the same time. So then we need to provide indices for start, stop, step. So it's what it's going to be. It's going to be start, stop, and step. All right, so we need to provide these indices. Okay, so how would we do it? So let's think. So oranges index 0, and mango is what? 2. Now there is one little thing that's like really confusing, especially for beginners. Stop index is not included. It's not included. So what I mean by that? So let me show it to you. So now if I want to get oranges and mango, so then it's going to be shopping list. I want to start at 0. Colon, that's index. And by the way, step is optional, so you might leave it for now because it's always there by default. It's 1. It's always kind of sitting there, and I'll show you step in a second. So 0 colon, and then I gotta do what? Then I gotta do 2. And you see, although index of mango is 1, but I gotta do one more, so it's index of that item plus 1, plus 1. So it gets me to 2. And you see, because stop index is not included. It's not included, all right? Please remember that. So that I know this is a little bit confusing, all right? Now let me show you another example. Suppose I want to do mango. Suppose I want to fetch mango and bread. So let's think about it. So index of mango is what? 1, right? So let me do this 1 here. And then what should I do for stop? If I leave it like this, it will just get me mango, but I was planning to get some bread too. So it's got to be one more. So 2 plus, like literally, I'm not sure if here I could do it like this. I'm going to get bread, so you see 2 plus 1. And again, like I don't want to do math in those square brackets. I'm just like showing you how it's done. And then it's got to be 3 because 2 plus 1 is obviously 3. So you see, and we get mango and bread. All right. So I hope that does make sense. Now, what if I want to grab bread and apples? This is where it gets tricky. All right. So let's think about it. So bread. So what would be bread? Index of bread would be what? 0, 1, 2. So we got to start at 2. Where should we stop? Where should we stop? So stop index is not included, so we gotta do one more, and which brings us to what? 0, 1, 2, 3, 4. But actually there is no 4. So, but let's give it a try. 4. Now you see I'm getting bread and apples. You could do it that way, but I won't do it. So usually if you want to grab all elements, and again, like I have no idea how many there, like, yeah, could be literally millions. So then I could leave it blank and it will get me the same result. So pretty much what I'm writing here, I'm saying, hey, I want to start at index 2, which is bread, and I want to go all the way, no matter how many I got, how many is there, I don't know. I just want to start at 2 and grab all of them. So for example, if I flip this to 0 and if I rerun this, now you see I'm getting the whole list, because pretty much what I'm saying, start at 0, which is oranges, and then go all the way. So that's pretty much what we're doing. All right. Now let me show you step. So step is the third argument here, and step is always quietly sitting there. It's a default one. So if I run it, it's pretty much doing nothing. So it means get me all elements from that list one by one, like literally one by one. All right. But if I change this step to 2, now it's going to get me every other one. You see, we're not getting mango and we're not getting apples. We're not getting them because we're kind of skipping them. You see, we're skipping them, and that's what step does. All right? So that's exactly what step does. Now, another thing how you might use step is sometimes you want to reverse a list, right? So you want to go in opposite direction. And remember, I just told you that plus sign, you could think of that as a direction. If you want to go from left to right, so you use plus sign. If you want to go from right to left, sign is negative, right? Okay, so in this case, what I could do, I could say that I want to start at -1, and we know that -1 is the last element, so means apples. And if I switch this step to -1, 2, and if I run this, what it's going to do, it's going to get me all elements one by one, starting from the end. So we're just moving in the opposite direction. We're moving backwards. So that's what's going on. All right. So yeah, you could do it like this. And by the way, you don't need even to place this -1 as start, although it helps, especially beginners. Now, kind of it makes more sense, but if you do it like this, you're going to get exactly the same result, because when you use step as a -1, it flips default values for start and stop. All right, so that's what's going on. So if you want to reverse the list, use negative sign -1. Okay, and what else? Usually, to kind of gain fluency, I would recommend to do simple exercise. So let me show it to you. You could create string, and suppose string goes like this: A, B, B, C, C, D, D, E, E. All right. Now suppose that's okay, so we're working with the list. I'm sorry, I just created a string, but string also could be indexed and sliced, and string, we'll talk about string some other time, but let's wrap it as a list, right? Since we're talking about lists here, so let me wrap it as a list, and here we got BB, all right, and here, okay, just give me a second. See, okay, so I don't want to take a lot of your time with this exercise. All right, so let's leave it at that. All right, so that's our list. Now, what I want to do, suppose I want to fetch all lowercase letters, like lowercase a, lowercase b, and lowercase c. So how would I do it? Pretty much like before, so that's a string, and then start, stop, step. So where do we want to start? We want to start at 0. Why? Because the index of lowercase a is 0. So what should we do for a stop? Pretty much nothing, because we want to go all the way, right? So we leave it blank. All right, so what about step? Since we want to grab every other one and kind of like jump over these capital letters, so we do it as 2. And let's take a look. See, we fetched all lowercase letters, right? So that's how you do it, and that's pretty much how you could grab every other element. Now, suppose I want to grab all capital letters from my list starting at capital C. So then, what should I do? So then, I start at what? At -1. What do I do for step? -2. All right, and you see we're going backwards. We're getting C, B, and A because step is negative. So we're kind of getting every other one. And here I have a couple of questions. Why shopping list cannot be from right to left for all elements? Because again, think of that like that. So write it down. Start, stop, and step. And you're kind of moving. You know, the step makes you move. All right? So now one more time. If you use negative number for a step, then you're going to be moving from right to left, but it's got to be step. So the question, I guess, so the question, okay, so all right, so I guess the question, something like this. So if we take the string, and if we just do -1 here and leave it like this, what we're going to get? Pretty much nothing, because what is going on? We're pretty much saying, hey, like -1 get me this number. So if you want to move, so you gotta do that step, which is -1. All right, so that's why we're moving. And one more time, if you use this negative sign at the end, so that's what makes you move, and it flips these default values. So you could actually do it like this. It's going to get you the same result. But just return the last element. If you want to return the last element, so then yes. So if all we care is this capital C, then we don't need to use slicing, then we use indexing. So again, the difference is indexing will get you one at a time, and slicing will get you many. It depends what you want to do. If you want to grab one, so then you do it like that. All right? Now, why do we need to use indexing? Because again, let's create a list. And by the way, interesting topic. Since I want to create a brand new list, now let me show you something. Now you see this a list, I use a list. I cannot use list. I cannot do like this because list is a function. It's a reserved word. So you cannot use it as a variable name. Please try not to do that, because then you're going to get an error message and then it's going to be like really confusing. So that's why usually you call it a list, b list, my list, whatever list, like shopping list or whatever. And let's create a simple list. 1, 2, and 3. All right. So indexing also helps us to reassign values, change values within a list. So what do I mean? A list. And if I use 0, I'm going to grab 1. Makes sense, right? Because 1 is the first element. Suppose I'm not happy about 1. I want to change its value. So then I could reassign a value. And now if you take a look, a list, you see I'm getting this 1. So you could change the value. You could replace the value by index, all right? So if I want to change 3 to 300, for example, so index of 3 would be what? 0, 1, 2. So then 2. And then I want to change it to 300. If you run it, now bam, we change it to 300, okay? All right, I hope it does make any sense. Now you're probably wondering, because we started with that, and let me show it to you one more time. Dir, and let's say a list. So again, this function will fetch you all methods for this object, which is a list in this case. And okay, so append is kind of like, we understand how to use append. So append just grabs an item and appends it to the end of the list. All right. Now, what about insert? Because insert sounds something we could use. Because remember, I asked you the question first. Now, how could you add elements? All right, insert. Now, suppose you have no idea how to use insert. That's okay because we're using Python. So what you should do, you should use help a list insert, run it, and I misspelled it as always. All right, so okay, one more time. Third time is a charm, right? All right, insert. Now you see, if you want to use insert, so it requires an index. It requires an object and an index. Now, what's the difference between append and insert? Append always appends to the end of the list, always. Now, what if we want to insert object at the beginning of the list, all right? So, or maybe in the middle, or maybe somewhere. So then you got to use insert, all right? So let's see how it works. So a list insert. All right. Now, so first, let's say I want to take an element, let's say 1,000, and I want to insert it at the beginning of a list, all right? So then it's going to be what? Index 0, because we know that 0 is always a first, it's a first spot, it's a first place within a list. 1,000, we run it, we're running this, and let's take a look. So now you see here we have this a list, and it's pretty much here, all right? So it's here. So now this is how you would want to use insert. Or if you want to insert, let's say, as a second element, so then 1, and then let's say I want to insert 2,000. Bam, done. You see, this is how you use insert. So there is a huge difference between append and insert. What about extend? What about extend? All right, so let's take a look. So extend works pretty much like append, however, and you see like this Google Colab kind of helping us. It's saying that extend requires iterable. Oh, by the way, what is iterable? All right. Now, iterable means something that you could iterate through, let's say with a for loop. And let me remind you that next week we're doing for loops. So please subscribe to my channel. And next Wednesday, same time, same place, we're going to be doing for loops. Like really cool. I'll show you a couple of cool things. All right. Now, so iterable, it's pretty much like it's got to be another list or a tuple or something else. All right. So extend, and extend will require another list. So here, if you want to use extend, you need another list. And let's say I'm going to do 10, 20, 30. So if I run this, now you see what just happened. It took these items, 10, 20, 30, and appended them to the end of the list. Now, if append takes and appends one object one at a time, so extend actually appends many items. So if you need to append many items, so you better go with extend, especially if you want to do something, I don't know, like for example, I use that every time when I do web scraping. Because when you scrape data from websites, and by the way, remind me to do another session on web scraping, and also like if there are some topics that you want me to cover, please write me as notes under this video. I'll take a look and we'll do something. Now, so for example, when you're scraping data, you're gathering a lot of data, and you don't want to like go one by one because you're grabbing like many items. So then I usually use extend, so that you see that does pretty much the same job, but it does it faster than append. You don't want to go one by one. All right. So there is one more thing that I wanted to discuss, which is very important because list is really, really popular and rookie mistake when people start learning Python and they learn how to use a list. They think that a list is a solution to all problems. No, you gotta know how to operate with different data structures. And what I mean like lists, tuples, strings, dictionaries, sets, all this kind of stuff. And you have to think about them as different types of containers. Because remember, I started with a box. I started with a box and I used that variable name. So because I wanted to put some stuff into that container. So the point I'm trying to make is all these containers, they behave differently. And although list is kind of cool one, again, it got some pros and cons, and it's kind of slow. It's kind of slow. Why is it slow? So let me explain you why is it slow. So I hope my iPad will work. All right. So let me show you something. Let me show you something. Now suppose we have a list. Suppose we have a list. Okay. And suppose in this list I have 1, 2, and 3. Pretty much nothing new, exactly what we did before. Now, these 1 to 3, these are not actual objects. What? Yeah, these are not actual objects. So these I don't want to. These are not variables, obviously, but they kind of reference into objects in memory. And since list is mutable, it means that we could add, I don't know how many items. Could be 3, could be 33, could be 3 million. So Python memory is not going to reserve that space in the Python memory for all these items. So it means that if you add items, they'll be stored in different locations pretty much all over Python memory. Like 2 is here, 1 is here, you see. So because 1, 2, 3 within square brackets, they're pretty much referencing the actual objects in Python memory. And when you iterate through a list or when you work with a list, it's kind of slow because it requires some time to locate that object in the memory, right? So what do I mean by that? So let me give you an example. Suppose you and a bunch of your friends, you go to a movie and suppose the movie pretty much sold out and it's difficult to find like spots to sit in that movie theater, and there are 5 of you and there is no way you could sit on the same row. So what do you have to do? You have to split up and sit like in different places, and then suppose you want to talk to your friend John. So if you want to talk to friend John, so first you got to find John. It's going to say, hey John, where are you? I want to talk to you. So it's going to take some time. So that's exactly what I'm trying to explain, and that's why list is slow, because you see these items, they pretty much stored in different places, and when you do something to list, it takes some time to find this. And I just noticed that you probably don't see that in the screen. So pretty much what I had there, I had something like this. You see, like all these items, they stored in different locations. All right. Now, again, when you work with a small list like 1 to 3, you won't see any of that stuff. But when you work with a list that has at least like 10,000 of elements, you kind of notice that it requires some time to do something to these items. So that's why list is kind of slow, and there are other data structures like immutable data structures that would be faster, like a tuple or numpy array or something like that. All right, so let me stop right here and please prepare your questions. And just to sum up, I just want to say a couple of things. So the main thing you have to understand that list is mutable type of data structure. All right. So data structure is just a fancy word for a container. all right, because it contains some data. So list is ordered collection of items or elements, whatever you want to call them, separated by a comma. And it's versatile because you could always add more items to a list, or you could remove items from a list, right? And then you could also index because it's ordered collection. So pretty much like you want to fetch apples from your list, so you gotta grab that item by index. And then you could also slice it if you need to grab a couple of them. So that's how you could do it. So let me stop right here. We got a couple of minutes left. Please let me know if you have any questions. Please let me know if you have any questions. By the way, next week again and again, I'm sorry I sound like a broken record. We're doing session. We're going to be talking about live session for loops. So please subscribe to my channel and let me know if there are other topics that you wanna do, like anything, and we talk about Python, so anything that is related to Python. All right, any questions? All right, then we're all done for today. So if you have no questions, if you have any questions later, so you could always send me your questions, and I'll try to give you answers next time. Please subscribe. So I'll see you next week, next Wednesday, same time, same place. We're going to be talking about for loops. All right. Thank you and goodbye.